Hi, let's talk about how camera works. And if it's your camera, your camera at home which you're making pictures, is it your camcorder or is it CCTV camera? This what we see here on that picture will be basically the same. So you have your object somewhere here. There's a distance from object to lenses. These are lenses of the camera. Usually it's in all those modern cameras that are built in. There are some cameras which you can replace lenses, but most of them they have built-in lenses. And this is distance between the lenses and the sensor. So the camera is built the way that you have lenses, light is coming through the lenses, hits the sensor, and then there's electronically transmitted to the DVR or NVR. So sensor is the electronic type of equipment. It detects light and has different sizes. So again, we have a distance between the object and the lenses. Then there's another distance which is between the lenses and the sensor, and it's called focal length. And we have a field of view, which is the length of the field. It will be in meters. Let's say it could be width, could be height, how much camera can see on that distance. And using those parameters, you can calculate that if you know your field of view and you know your sensor and you know the object distance, you can calculate what type of lenses, what focal length of lenses you need with certain sensor type size. And here are some examples of sensors. You have 1/3 of inch, 1/2 inch, 2/3 of inch, 1 inch. More than that, but in CCTV, let's say they're pretty common. And at the same time, you have sizes in millimeters, length and height, length and height, length and height. And then you can calculate, knowing what sensor camera will have. You can calculate, let's see if I have there is that. You can calculate what focal length you need, knowing what sensor size camera will have. So you have focal length, that's what we're looking for. So we're trying to establish what sort of lenses you need. You have to know the chip size in millimeters. That's what we were looking on this slide, yeah. And you have to remember that if you your object, taking the width of the object, you have to take the width of the sensor. If you're taking the height of the object, you have to take the height of the sensor. You have to stick to that, yeah. And so you have your focal length will be chip size in millimeters, and as I said, either vertical or horizontal, depending what you measure, multiplied by object distance and divided by object width, and you will get focal length in millimeters. That's how you can calculate it. So you must know your object or maybe field of view, object width would be object or field of view required, distance to the object, and if you know this, you can calculate that. And let's have a look here. It just gives it will give us a little better understanding how it works. As you can see, the bigger the focal length, the better zoom in you get. As you can see the violet ones, it's 8 millimeters, its focal length, and you can see the same size on much farther distance. See, angle view is smaller and distance is growing. So that's basically how it works. So with 2.8 millimeter lenses, that's a focal length, you're getting about 80 degrees view, and you can see at the distance, let's say 3 meters. 3.5, you get smaller, angle of view, but longer distance. So basically that's a zooming in. When you're zooming in on something, you making your focal length bigger. I mean, you're making the distance between the lenses and sensors bigger. That's how you zoom in. And that's basically how camera works. So you have all that information. It's very basic information, but it's important. Whole thing, light goes through the lenses, hits the sensor. This is transferred electronically, and depending if it's HD camera or analog camera, you're getting uncompressed signal sent over the coax usually. When it's an IP camera, signal is being compressed and encrypted and sent over the network cable. But that part is basically the same. Thank you.